So one possibility then would be to go on to dispositional theories of colors. That is, colors are the dispositions to produce particular experiences. And there, of course, the best known one on our list, of course, and those of you who have the misfortune to be in philosophy 128 have seen some of it already, it's 5. Because 5 seems to be Descartes and Locke's secondary quality theory of color, lumping them together for the moment. The difficulty with treating colors as real because they are dispositions to produce particular experiences. Here I'm going to follow Joshua Gert's argument on the subject. If you look at Gert in his essay, it's called What Colors Could Not Be. If some of you have run into Paul Benaceref's What Numbers Could Not Be, it's a chime on that essay. Let's say some of you are familiar with, if you've had 160, you are familiar presumably with Frege's logicism. If you've taken philosophy of language, you've heard about Frege and his, in his semantical theory. He started out as a logician. He was in the math department. And so he proposed the thesis that mathematics could be reduced to pure logic. In other words, Kant was wrong. The difficulty with it is that the reductivist proposals seem to be unconstrained in a way that philosophers have enormous fun with, right? We love being unconstrained, but but the lack of constraint then sheds doubt on any particular proposal for the reduction. So, for instance, some proposals for reducing numbers, let's say the number 1 through 3. Proposal 1. The number 1 is simply the singleton set whose sole member is the null set. Talk about creating something out of nothing. Set theory does give you this godlike power. Then set member, succession, that is, the relation between the number 1 and the number 2 is going to be merely set membership. So the number 2 is going to be the singleton set containing solely the number 1, which is the singleton set containing solely the null set, etc., etc. So succession is a matter of adding races. One set of races to the front and the back at every iteration. Proposal 2, a little more complicated. The success, again, 1 equals the singleton set consisting of the null set, but the successor function is the small power set. Small power set is the power set not including the improper subset, right? The power set of a set is the set containing all of the subsets of that set, including that set itself. Proposal 3, why not go all the way? Just like 2, except the successor function is the full power set. Lots of possible reductions, each with their own advantages and disadvantages. The set with which each member is to be identified seems, again, unconstrained, in a way that a genuine reduction by theoretical identification should be constrained. 2 problems arise. First, determination of which set the number 3 is identical with seems arbitrary. Second, the attempted reduction seems to raise philosophical questions which appear to be utterly gratuitous. in fact, may not have sense at all. For instance, on the first reduction, the number 3 contains the number 2, but it does not contain the number 1. Right? It's the set whose sole member is the number 2. But it doesn't, strictly speaking, contain the number. The set that's identical to number 2 contains the number 1. But the set 3 does not contain the number 1. Where, of course, on the second and third proposals, the number 3 is going to have the number 2 as a member. It's also going to have the number 1 as a member. Well, does the number 3 contain the number 1? Or doesn't it? The obvious answer to this question is, the question is misconceived. Right? In other words, this reductivist program is going to entail, as part of its reductive theory, that numbers have properties that they just don't have. That shows that there's something wrong with reduction. Conclusion. Benaceref's conclusion in the essay was, numbers form an autonomous domain. Arithmetical truths do not need to be explained in terms of anything other than the basic truths about numbers. 8, color theory 8 on the list says, likewise for colors. Basic truths about color need not be explained in terms of anything outside the domain of color. And the reason why we cannot explain these central truths in a reductive way is that, ontologically speaking, colors are just primitive. They're basic properties in the world. Now, I was expecting people to go up the flue when I said that. But, facts about reflectance properties of surfaces and facts about the neurology of the visual system are crucial for understanding color, for understanding our experience of color. And those are facts that are both outside the domain of color and explain truths about color. And again, here is where I have my problem, that given we have to start in metaphysics with something real. Now, it is possible, it is possible to say, as Wittgenstein said, okay, once we have come to a correct understanding of the world, by climbing up a particular ladder, we can kick the ladder away, once we've gotten there. And that happens, doesn't it? Where you realize that what you presumed, what you were looking for an explanation of, will disappear upon the receipt of the explanation. You realize that it will vanish into the explanation completely. But I don't think that the understanding provided by the reflectance properties of objects or the physiology of color vision, everything that Mary the neuroscientist knows without ever having seen colors, is crucial for understanding colors. Normally sighted people have an understanding of color and are masters of color concepts. They know some important truths about color. They know that red merges into yellow in one direction and into blue in another, but not into green directly except through either yellow or blue. They know that ripening bananas go from green to yellow and then to black, where Granddad will still eat it. So that's when they're left for me. The claim being advanced here is that what the sciences of color and vision tell us about color is not what the sciences of color do not tell us is what red and blue and what being red and being blue are. we already know what they are. Furthermore, colors are not the sorts of properties that can be explained or determined in that fashion. Well, the objection, I know what you're all thinking. You're thinking, well, we have a perfect, people for hundreds of years had a perfectly good grasp of the concept of water without knowing that the term water designates, indeed rigidly designates, H2O. Except on Twin Earth, where rigidly designates
familiar from last semester.
Something else. But surely when we learn that water is H2O, we learn what water is. Why don't, when we learn the scientific explanation of color, do we not learn what color is? The issue is precisely, then, whether one of the reductivist accounts of color plays the role of telling us what color is. And one answer is that colors are among the sorts of properties, along with, I would submit, prices, values, and beauty, that cannot be specified in this way. So, which of these two analogies, the analogy with Frege's reduction of number, or the analogy with our reduction of water to H2O, which of those analogies works best for color? Well, physics has no alternative account to offer of water. There are no rivals clamoring for attention. No, it's not H2O, it's something else. Logicism is completely unconstrained, has a completely unconstrained array of choices on how to reduce numbers to sets. The lack of constraints indicates that, in fact, the gears are not engaged here at all. No matter how fast you pull any of the levers on this, they are not, in fact, moving anything. They are not explaining anything. As the list indicates, there's a very wide variety of possible reductive accounts of color. The usual strategy that all of these very clever philosophers that involved in the infighting amongst each other between the different reductive accounts, the main strategy is to show that your opponents attribute to colors properties that they don't have, and yours doesn't. Either properties that they don't have, properties that they cannot have, or properties that it simply makes no sense to attribute to them. And the argument goes then, any reductive view is going to give colors properties that they do not have. Therefore, color is... Now, this is not to say that a great many facts about colors are going to be explained scientifically. The claim is that, unlike with water, the scientific explanations are not going to tell us what colors are. So, and again, it was similar to the argument I was making last semester about the neurophysiology of mental states. Contingent minimal functionalism may tell us how mental states are physically realized in the actual world. That is not a solution to the mind-body problem. How do we learn color terms? How do we learn color concepts? Preston?
Slightly demonstratives. That's red.
Oh.
Wait. And you tell
That's
us,
red.
oh, that's red. Yeah.
If we grasp color concepts, if we master colors, it is in virtue of the contents of certain visual experiences we have. Now, because of the multiple realizability issues I was laying out before, it will not constitute an explanation of what color is to involve any actual physical property of the object being observed in our concept of color. Too many properties are liable or could produce that color as a content of our visual experience. Furthermore, it would involve us in obviously misconceived counterfactuals. Like, if the light from the sun, or if the light from the sun were different, or if the laws of physics or something like that were different, would that object still be that color? And that's the main problem with the reduction of color to physical properties, even dispositional properties. Those counterfactuals start making sense. They rise up and demand answers. That is, they assign modal properties to colors that it is misconceived to think that those colors have. So the difficulty with all of the proposed reductive accounts of colors is that they all fall afoul in one